Well, it's Ryzen Central over here, and the ASRock TaiChi X370 has got the first mover advantage. But will they be able to something sports analogy? Stay tuned. We're here to take a look at the ASRock X370 TaiChi. TaiChi, it's sort of, I like ASRock what they're doing with this TaiChi thing. I mean, the aesthetic of the TaiChi boards that I've looked at, Z270, Z170, X99, you know, this black and white gear, but the philosophy of the TaiChi boards from ASRock is that they're trying to give you the features that they think are most important for users without giving you any of the crap or any of the stuff that might add to the overall price of the hardware. And I can appreciate that. And it doesn't seem like the X370 TaiChi is any exception to that pattern. This is an AM4 version of the TaiChi, or in the TaiChi family. And that means it supports AMD Ryzen. So the R3, R5, and R7. At the time of this video, only the R7s are out. And actually, technically, the R7s are not actually out. I've got an R1700X. But we're going to pick up an R1800X tomorrow. I don't have my hands on it yet, but all of our testing has been done with an R1700X. And also all the testing that I've done with this motherboard has been with DDR4 2133 ECC memory from Kingston. Yes, error correcting. And Linux, mostly Linux testing so far. I haven't really done a lot of Windows testing because I haven't had the board for a very long time. This is, I think this is probably the only video that we'll have out on or around launch day. So let's take a look at the board. Now, the first thing that you notice is that there is a substantial power delivery circuit here. I mean, this is, you know, supposedly a 95 watt TDP CPU, but look at this. Look at the VRM circuitry here. It's a 12+4 power phase design. That tells me that this thing can deliver up to 300 watts through the AM4 socket. That's kind of nuts. I don't think that I'm going to be dumping 300 watts into this thing anytime soon. This also has the ASRock Hyper-B Clock engine too. The name of the ASRock X370 chipset is Promontory, so that sort of provides the connection. Now, this is a really weird thing. You've got to have a block diagram of the motherboard to really understand this. The X370 chipset has 16 PCI Express lanes dedicated for the graphics or whatever. That can be configured as 2x8, and that's how most motherboards are doing it. There's also a PCI Express 3.0x4 dedicated for NVMe or SATA Express. Most motherboards seem to be configuring it for NVMe, which makes sense to us, so that's good. Then there's a PCI Express 3.0x4 connection to the rest of the chipset, to the other peripherals in the system. And that PCH provides PCI Express 2.0 connectivity, more USB ports, more SATA ports, that sort of stuff. There are also SATA ports that are provided directly through the CPU, and there are other resources such as USB 3.1 Gen 2 that are provided that way as well. Now, the PCH does also provide even more USB connectivity. So the thing to note with that is that, so like if you're comparing this to Z170 or Z270, on Z170 and Z270, you might have two M.2 slots that both have PCI Express by 4 connections. And those two PCI Express devices would share that PCI Express by 4 bandwidth ultimately through the DMI on an Intel platform. AMD, no, there's no bandwidth contention there. You've got one M.2 slot that's wired directly into the CPU, but your other M.2 slot is through that PCH. Unfortunately, that means that because it's using the PCH lanes, the PCI Express version is going to be PCI Express 2.0. So we're talking 16 gigabits per second instead of 32. Although I've noticed a lot of motherboard manuals have started referring to it as 40 gigabits per second for PCI Express 3.0 4 lanes and 20 gigabits per second for PCI Express 2.0. But I've done the math and I'm pretty sure that that's 16 and 32. But if anybody has any hints about why suddenly Intel is referring to that as the 16 gigabits of bandwidth is 20 gigabits of bandwidth, and the 32 gigabits of bandwidth for the PCI Express 3 version of that as 40 gigabits of bandwidth, do let me know. Probably something to do with USB Type-C and Thunderbolt, but I think in the context of PCI Express lanes, it does not matter. So let's take a look at the expansion capabilities on the board. On this board, we've got 3 by 16 slots. Now the first one is by 16, the second one is by 8, and so if you're gonna run 2 peripherals in that, it's gonna be by 8 by 8. Then we've got a by 16 on the bottom, but that's electrically by 4. Now this shares bandwidth with the M.2. So if you're going to be running the second M.2, M.2_2 is what it's designated on the motherboard, then that slot will be disabled. So if you have a PCI Express NVMe, you can use it in the bottom slot, or if you have like a normal M.2, you can use that in the second M.2 slot, but it will operate in PCI Express 2.0 mode. It also provides two PCI Express 2.0 by 1 slots, and there is a third M.2, which is what the Wi-Fi is using. That's an E key, so do keep that in mind. For audio, it's a 7.1 channel audio codec. That's a Realtek ALC 1220. That's got the Blu-ray audio support, has surge protection, that kind of thing. Its Purity Sound is the implementation from ASRock. That means Nichicon fine gold audio capacitors, 120 dB signal to noise ratio. It's got a TI NE5532 premium headset amplifier for the front panel, which supports up to 600 ohm headsets. Pure power in, direct drive, PCB isolation. The audio part of the PCB is isolated, so that's good. It's got RGB LEDs behind the motherboard so that you can light that up. Gold-plated audio jacks. It's 15 microns of gold audio, DTS Connect, all that. It's got an Intel, surprisingly, i211AT gigabit Ethernet adapter, which has lightning protection, supports 802.3 AZ, power saving, and of course PXE, so you can boot from the network. It also has a built-in Intel 802.11 AC 2x2 dual band Wi-Fi adapter. So that was supported in Linux. That worked completely fine. That also supports Bluetooth 4.2, 3.0, and high-speed class 2. Everything with the wireless adapter, as far as basic Bluetooth support and 802.11 AC, worked under Linux, as did the audio codec. We did most of our testing under Linux. At the back, we've got our two antenna ports, our one PS2 keyboard mouse port, optical SPDIF, one USB 3.1 Type A. This is USB 3.1 Gen 2, so that is 10 gigabits per second. We've got one USB 3.1 Type C, also 10 gigabits per second. 6 USB 3.0 ports that have the electrostatic discharge protection. Our RJ45 LAN connection, clear CMOS switch, and our HD audio jacks. For the front edge of the board, we've got 10 SATA 6 gigabit per second ports. 8 of which are provided by the AMD chipset, some of which are directly through the CPU, and some of which are through the PCH. And then we've got 2 that are provided by an ASMedia ASM 1061. Those all support hot plug, AHCI, that kind of thing. And we've got the 2 M.2s that I mentioned before, one of which is PCI Express 3.0 directly into the CPU. Those are both, both of those support bootable NVMe devices, and supports the ASRock U.2 kit in case you've got a U.2 NVMe. Now there are 2 RGB LED headers on this thing that support up to 12 volts and 3 amps, so that's a 36 watt LED strip. We've got a 4-pin fan connector. We've got a CPU optional connector as well, which is a 4-pin. It also supports smart fan control, and it will deliver up to 1.5 amps for a water pump. We've got 2 chassis fan connectors, 4-pin for smart fan control, and then we've got 1 chassis optional / secondary water pump, which is another 4-pin connector. CPU fan and the 2 chassis fan connectors can auto detect if a 3-pin fan is used, so those 3 connectors will support 3-pin fans. There is also 1 additional RGB header, which is for the cooler that AMD provides that has built-in RGB. And then there are 2 onboard USB 2.0 headers and 2 onboard USB 3.0 headers for the front panel connections. Well, it's USB 3.1 Gen 1, 5 gigabit per second, so, but everything in the manual refers to it as USB 3.0. Literally everything is new, and there's a ton of bugs. There's just bugs everywhere. And it's not necessarily a bad thing. Like if you're the adventurous sort, if you use Linux and you're not afraid of Linux and you're not afraid to get your hands dirty, it really is a tremendous amount of CPU horsepower for not a lot of money. And 8 cores, really, you shouldn't underestimate that, because it's like, oh, 4 cores is enough. If 4 cores is enough for what you're doing, then maybe right now the Ryzen 7 processors are not for you. But overall, the platform is really promising, and I would totally run this for a Linux machine for myself if I really, if all things considered. I would, like, if I were building a system today and I wanted the best bang for my buck, knowing that it's probably going to be a Linux workstation and I'm probably going to use it for work about 3/4 of the time, maybe some light gaming, totally going to be a Ryzen 7. 8 cores, good CPU support, does have error correcting memory support, at least it seems to, on the ASRock X370 TaiChi, more on that in a moment. Windows 10 is supported. Windows 7 on this platform, I don't know, you're taking your life in your own hands. I mean, come on, just Windows, just go with Linux. Maybe even BSD. I need to test these with BSD. That might be a thing, I don't know. It's It's getting crazy around here. So for the testing, you should keep in mind that we started our testing with a 1700, but now the retail launch date has passed, and so we picked up an 1800X, and somebody else that we know picked up a 1700X, and so we've got it for a few days for our testing. So in the video, you'll hear me refer to a 1700 and a 1700X testing, so things are a little bit muddled. There have also been several Uefi updates since we started our testing, which completely changed the test results. So Linux testing, first off, graphics card. Yes, everything is fine. You can run 2 graphics cards, but the 2 graphics cards that you might run in the by 8 slots are in the same IO-MMU group. So if you're gonna do GPU pass-through, it's not gonna work. At least you're not going to be able to split it. Maybe there's a patch, maybe there's something. I'm working on that, stay tuned, but as of right now, no, same IO-MMU group. IO-MMU group 0 is the X370, the South Bridge. So literally everything connected to the X370, that's your legacy PCI Express 2.0 lanes, which is that the bottom X4 slot on the motherboard, that's connected through the X370. So you're not going to be able to run a graphics card in that. Well, you could run a graphics card in that and maybe pass through the one in the slot directly wired into the CPU, but in order to do that, you have to enable the graphics card that was not enabled by the Uefi, by the system board Uefi at boot time, and that gets tricky and weird, and I don't know that that can be distilled down into a one-size-fits-all how-to guide, but hey, we're going to work on it. There's some members of the community that are probably going to help with this thing, because it's a great platform in terms of, you know, lots of cores, 64 gigabytes of memory support, maybe more than that, and error correcting memory, so that you can do a lot of fun stuff with this in Linux, a lot of fun stuff with this as far as virtual machines go. Just got to get that PCIe pass-through going. So in the future, something called SRIOV, where you can share one graphics card among operating systems, may also be relevant on this platform. But as of right now, since I believe that only Intel and actual workstation class graphics cards support SRIOV, it would be a little off topic to discuss it further in this video. Just be on the lookout for SRIOV things, and you know, bring me interesting stories on the forum so that I may digest them and distill them into a video for you if you like. In terms of other Linux support, SoundWorks, it's ALC 1220 codec, no surprises there. Networking, Intel networking, this board's got wireless and wired. Both of those work fine under Linux. Even the CPU frequency control in user space totally works fine. I was able to step between 3.6, 2.2. Honestly, the only thing that I had to fiddle with, and this is probably going to be fixed by the time that you have to deal with it, is the 1800X will clock up to 4.0, 4.1 gigahertz. And I had to fiddle with that a little bit because it only wanted to clock up to 3.6, which is what we had with our 1700 sort of out of the box. But the 1700X and the 1800X have a little bit wider FRX frequency range, so take that with a grain of salt, if you will, for whatever it is that you happen to be doing with that. Really disappointed about the IO-MMU situation. The IO-MMU situation, here's the groupings on screen. It's really, I mean, you look at it, it's really not the greatest. So, okay, now back to our regularly scheduled motherboard review. We're going to be doing more formal Ryzen testing over the next couple of weeks. Haven't really had a lot of access with the platform so far, and I figured the most important thing to test for the sort of out the gate thing is the Linux stuff. I do have a Windows test install, and I have done some testing with Windows. Not sure what's up with the memory latency. The Windows memory latency testing tools report 100 nanoseconds. The Rowhammer utility from Google reports 30 nanoseconds. The Rowhammer utility reporting 30 nanoseconds, that's only half of a round trip. That's to get stuff into memory. So you double that to get something in memory and back out. So 60 nanoseconds, which is about what I would expect for the platform. Maybe 100 nanoseconds is normal, I don't know. Again, 2133. All in all though, 8 cores, 16 threads, $400 retail price, relatively inexpensive. I'm not sure what the final retail price is going to be on the TaiChi X370. I imagine it's going to be competitive like all of the other TaiChi parts, but you know, do some comparison shopping, look around. All right, well, it wouldn't be a motherboard review without a quick tour of the Uefi. I almost forgot this, so this is just going to be a tour of the Uefi screens with no voiceover, hopefully a little light music or something like that. But I do want to mention some sort of unofficial, official overclocks and stuff like that. This is the TaiChi running at 4.2 gigahertz. Yeah, 4.2 gigahertz. It's mostly stable, but I do have to run a little hot with 1.46 voltage. Now, AMD doesn't recommend any voltage past 1.35 volts, but as long as you can keep up with the cooling and you're willing to risk a $500 processor, you can push the envelope a little bit. I think as the firmware improves and the microcode improves, we'll see some better stuff with this. But holy crap, 4.2 gigahertz. There's a link to the validation in CPU-Z. Now, something interesting I saw on CPU-Z is that the single thread performance in the built-in CPU-Z benchmark actually exceeds a 7700K at stock speeds, which presumably it's 4.5 gigahertz because of the stock boost. So I'm not sure what to make of that, given that single-core Cinebench would actually be higher than the Ryzen. I'm not sure if what Cinebench is doing is more optimized for, Intel's platform or something like that. I would be curious to know what CPU-Z is doing more under the hood. But this isn't a benchmarking video. This is really just about Ryzen. And with the latest firmware updates, the very latest bleeding edge firmware updates on the TaiChi motherboard, 4.2 gigahertz, 3200 megahertz memory, and 3200 megahertz is stable on the DDR4 with this motherboard. So that's really something. That's using the G-Skill Trident Z memory kit. I've also used the Predator DDR4 3000 kit that is, quote-unquote AM4 certified. And the AM4 certification includes an XMP profile that runs at 2933 in case you're having problems getting some of those higher memory clocks. And here's our Uefi. Now, the only fun thing here is that the ASRock Uefi, at least right now, lets you get at the P states on the CPU. Now, the P states are the power management states. You can actually overclock through the P states instead of quote-unquote a manual overclock with multiplier and voltage. This is fertile overclocking country, I think, for messing around with the CPU. So we'll see how that shakes out. I'm not really super into overclocking. I'm super into getting IOMMU groups and things to work stable in Linux, but it is what it is. So far, I like it. So far, it's pretty stable. The Uefi is a little squirrely. There are references to Intel in the Uefi when talking about the load line calibration and some of the other overclock things, which I don't think is relevant, but maybe. Those things will get ironed out as the software matures. So we're looking at a brand new platform with brand new software. It's going to be a little rough around the edges to start. But if you're an enthusiast like me and you really want a lot of cores, 8 cores, you know, Ryzen's looking like it's a pretty good platform for massive parallel computation. I'm not sure about Ryzen for 1 or 2 cores, things that are not super heavily multi-threaded. I'm not really sure about that. I still think that the 5 gigahertz quad core from Intel is going to be really hard to beat for that scenario. But in terms of like the super expensive, like the $1,700 and the $1,000 parts from Intel, yeah, we don't have as much PCI Express bandwidth, but for your everyday user, what does it really matter? That's just my opinion though. So if you pick up one of these or you build a system or whatever, show it off in the forums at Level 1 Techs. I'm Wendell, I'm signing out, and I'll see you later.